All right, first let me apologize. I totally screwed this up in class, so I want to try to fix it right now. Keep in mind, if you're asked to find increasing function or decreasing function and they give you this graph, one of the things you can do is you can find the stationary point or points and then figure out whether they're a maximum or minimum. Now, the best way to do that is to use a second derivative, but you could also do it graphically, and that's what this question is kind of about. So first we start off by taking the derivative. We get this, and as we found out in class, when we try to make it equal to 0, it didn't factor. And what made it worse is that when we tried to use the quadratic formula, we found out that the x was equal to a complex solution, which means that the graph never touches the x-axis. In this case, we ended up with 12 plus or minus negative 36 over 18. And I can just stop right now because the discriminant is negative. It's not going to touch the x-axis. So what's going to happen is it's going to look something like this. Now, what I told you in class was this is a graph of all the possible slopes. This is true. Now, there's other situations that could have happened, and let's look at those also. In this case, you got to keep in mind that though we're looking at a graph of all the possible slopes, where it touches the x-axis is the stationary point. So in this first case, our problem, there's always a positive slope. Notice how they're always positive. They're always above the x-axis. And there is no stationary point because it never equals 0. This original graph is going to look something like this. Now in this second example, it touches the x-axis once. That means there's going to be one stationary point where there was no stationary points in the first one. In this one, we know that there's one stationary point. And if you look at the values of the slope, they're positive before and they're positive after the stationary point. Well, this is called a point of inflection. And you don't have to worry too much about it because it's going to be covered more in the next class A. But it is a situation where the graph will slow down and then become 0 for a slope for one point, but then it'll continue going up. And it'll look something like this. Okay? So that's the original in this case. Now, in this next one, again, we're looking at a graph of the derivative. There's two stationary points. And you'll notice that before the first one, it's positive, and after it's negative. So that's going to make this one a maximum because before the point it's positive and then after it's negative. In the second stationary point, it's negative before it and positive after it. That's going to make that a minimum point. So to give you another example, if you pick a really simple one, for example, we'll say y equals x squared. All right, so let's take a look at this. If we do an example for y equals x squared, now you know that it's going to open up and it's going to have one stationary point and it's going to be a minimum. But let's do the derivative and we find out it's 2x. So we do the 0 equal 2x and we find the stationary point is at x equals 0. Here, I'll put a graph up here. So now here's the original. Looks like that. Notice our stationary point's right at 0 and it's a minimum. Now here's a graph of the derivative. The graph of the derivative is going to look like this. Y equals 2x. It's going to go through the origin. But the thing is that stationary point, it's at 0, so that's where it is. But you'll notice it's negative before and positive after. Minimum, because the slope before our slope before the minimum is negative, and afterwards it's going to be positive. So I guess the bottom line is, if there is no equal to 0, then it doesn't have a stationary point. And I hope that helps. Feel free to email if you got any other questions. Thanks.